Hello everyone, today we're going to be looking at problem 13 of the 2026 FEGOS MA exam. First, I would like to start off with the joke of the day, which is, why did the chicken cross the road? Whether the chicken crossed the road or the road crossed the chicken depends on your frame of reference. Okay, so let's get back to the problem. Let's start by reading it. A block of mass m slides along a surface with coefficient of kinetic friction mu k. The block is confined to move between two walls separated by a distance L. Attached to each wall is an ideal, perfectly elastic spring with a very large force constant K. The block is launched from the midpoint between the walls with an initial speed v0 directed toward one of the springs. It bounces back and forth between the springs, losing speed only due to friction with the surface. Assume the time spent in contact with the springs is negligible compared to the travel time between them. Which of the following expressions correctly gives the total time t required for the block to come to a permanent rest? Okay. So first let's draw a diagram. There's two walls, and there's this block sliding between them, and there's these springs, right? So first of all, from reading the problem, we know that there's losing speed only due to friction, so that might give us the idea to use work or energy. And so let's look at the springs first. So it says that the springs have a very large force constant, and if there's a larger force constant, that means it's more stiff. So if it's very large, basically we can assume that it's so large it's basically a wall. So this thing is, because it's so stiff, it can basically be a wall. So then we can simplify this into only two walls, and there could be, it's just moving back and forth. And since it's only losing speed due to friction, so it's what it's asking is the total time t. So now we can use momentum and impulse to solve this. So basically we know that the force times the time equals delta p. And the reason I decided to use momentum impulse is because there's the speed from here and the time here, and this equation relates both of these. So it equals to delta m, which is, it's just the same m. So m delta v, and that's going to be equal to m. So it says time to get to permanent rest, and at rest v is 0, and it starts at here, v0. So it's going to be just, well, technically it would be negative v0, but then the force is also negative, so yeah, and the force is equal to negative mu mg, because F is equal to mu n, right? And it's opposing, so we're just gonna say it's negative here. And times t, and I'll just use capital T because that's what the problem says. It's going to be equal to negative mv0. So, oh yeah, and this is mu k. So then we get that t equals, and since the m's cancel out, right? The m's cancel out, so t is going to be equal to v0 over mu kg. And that is going to be our answer choice C. Okay, thank you for watching. If you have any questions or comments, please leave those in the comment section, and make sure to like and subscribe. See you in the next video.